Hello guys, my name is Balakrishna Srivastav and welcome to Code with BK. So in this video, we discuss the concepts and the C code to insert a node at the end of the linked list in C programming. So before we begin, it is a request to please subscribe to my channel, and if any of my previous videos or if this video helps you out, so please do subscribe to my channel. So in the previous videos for linked lists in C programming, we saw what are linked lists, how we create nodes and connect them, we link them together to create a linked list. Then we saw how to print a linked list and insert a node at the front of the linked list. Okay, in this case we have to insert a node at the end of the linked list. Okay, so if we have a linked list, and this is my head, okay, the head of the linked list should always be pointing to the first node of the linked list, and the next of the last node should be null. Visually, this is how we represent a linked list. Generally, you will see this in a lot of references where this circle or maybe a square represents the node object. In case of C programming, it is a struct node object, the value inside the data which is inside the node. In this case, it is an integer, all right, and then this arrow represents the next node that we can go to from the current node. Okay, so from the node containing the value 2, you can go to the node containing the value 33, then to 88, 197, and the next of the last node has to be null. Okay, so we have null in all uppercase in C and C++ programming. Sometimes I'll write it as lowercase. Okay, no difference. We have to insert at end. For example, if I have x equal to 65 that I want to insert at the end of this linked list, so the linked list that I want is, okay, the linked list remains the same except that we have a new node 65 at the end now. Okay, so next of 97 was null, which is now replaced by next of 97 is 65, which is the new node added, and then the next of this is null, and head remains at the same place. Okay, so first we discuss how this linked list is stored in memory, so that when we create a new node and add it to the end, how links work, what are the changes that go behind the scenes, and then we look at the code and run this. Okay, so if I have to represent this linked list 233, 8, 197 and null with a head pointer in the memory, I have something like this. Okay, so representing this linked list in memory looks something like this, where we have the head pointer. Head will store the address of the first node which contains the value 2. The next pointer inside 2 points to the node where we have stored 33. So the next variable inside 33 points to the node containing 8, then 197, and the next of the last node is null. Okay, since we have 5 nodes, we have 5 corresponding structs, each struct node for each of these nodes and the corresponding values inside. So each struct node gets its x and next, because each struct node contains two members, x and next. Okay, so you can see each struct node object gets x and next. Okay, and the head pointer stores the address of the first node. And if you want to go into details on how we achieved this diagram of structs being connected to each other, I recommend you watch the first few videos where I explain how node objects are created and connected, and also the video to insert a new node at the front of the linked list, where in very detail I've explained how all this is working, okay, in the memory behind the scenes. Okay, so in order to insert x equal to 65, all I have to do is set the next of this last node, which is storing null, to a new node. Okay, set the variable x to 65 and set the next of this to null. So let me just write the code for this first, okay, and then I explain this how things happen in this memory. So I'll say node insert at end. Okay, again takes the head of the linked list, at the end of which we need to add a new node with the value x. Okay, return the updated head. Again, if the list is empty, okay, if there is no node in the list, adding at the front, adding at the end means the same, because the list was empty and you're adding the first node either at the front or at the end. It is just adding the first node. Okay, so the code for head equal to null remains the same because the list is empty and you're just adding the first node. Else, if the head is not null, okay, the list is not empty. Okay, in the case where the list is not empty, you have to move to the last node. Okay, then create a new node. Okay, set next of last node to this new node. Okay, something like creating a new node here, the next of this last node. Okay, the next of this is going to be null, and set the value x equal to 65 here. Okay, we see how we do this. Okay, so moving to the last node, we take node current equal to head. Okay, I'll say while current dot next is not equal to null. Okay, I say current equal to current dot next. Okay, at a lot of places when you read about this, you might find something like this. Okay, This means that if the value of the reference inside is null, then it evaluates to false. The condition evaluates to false. And if the value inside the reference, if this is not null, it points to an object, then this condition evaluates to true. Okay, so you can say something like this, which is saying current.next is not equal to null, or also say something like this. Okay, I'm going to stick with this. So at the end of this while loop, you have moved to the last node, so you can say current is at the last node of the linked list. Okay, then you create a new node, so we can do copy this. Okay, set the x value. Okay, and set the next to null in this case. New node dot next is null in this case. Okay, because we are adding at the end and the next of the last node has to be null. So if you are adding a node at the end, make sure its next is null. Okay, then you set the next of the last node to this new node. So you said current.next is new node, and this is your code to add a new node to the end of the linked list. Okay, so following this code, if we have to add x equal to 65 at the end, okay, we start with head pointing to this, okay, and my current pointing to head. So I have a variable current of type node pointer pointing to where head is pointing. Okay, I say current.next is not equal to null. That is, the next of current, is it null? No, the condition is true. So current.next is not equal to null. Condition is true because current is pointing here. You say current equal to current.next. This means wherever current.next is pointing to, current is going to point to that. And in terms of copying values, the value inside current.next is copied to current. So whatever address is inside the variable current.next is copied inside the variable current, which essentially means that current is now pointing to where current.next is pointing to. Current.next is pointing to this. The next inside current is pointing to this. So current now also points to this. Okay, you go back to check for while loop condition. Current.next is not equal to null. Current's next is pointing to this, not null. You do current equal to current.next. Current now points here. Okay, again you go to check for while loop condition. So it was true, it is still true. Current.next is not equal to null, true. You do current equal to current.next. Current.next is pointing to this, so now current also points to this. Okay, then again you check for while loop condition. Current.next is not equal to null, true. Then you say current equal to current.next, so current now points to this. Okay, then you say current.next is not equal to null. Current.next is null in this case, so condition is now false. Condition is false, you come out of the while loop. Current is at the last node. Current is at the last node, which is the last node of this linked list, 233, 897 and null. Current is pointing to the node with the value 97. Okay, the next of which is null. Then you say this, create a new node with the address of this new node storing into this variable. So creating a new node, the address of this new node, okay, is in this variable of type node pointer. It gets its x and next part. Okay, the values of which it is unknown, garbage value when we are doing this. Okay, because malloc will not set the bytes to 0. Okay, then you said new node dot x is x value that we are trying to insert is 65, right? Okay, so this gets 65, right? And you set the next to null, so this now is null. Let me just clear this. Okay, and then you say current.next is new node. That is, whatever value was inside new node variable is copied into current.next. That is, whichever node new node is pointing to, current.next is going to point to that. Whichever node new node is pointing to, if this value was say addrq, so this also stores now addrq. So this also stores addrq, whatever be the hexadecimal value of the location, and this points to this. Okay, and then you return the head in the either case, updated head. Okay, just as we did in the inserted friend. Okay, so when the function returns, the local variables are lost. Current is lost, this new node variable is lost. Okay, current is lost. So what you get is this current is lost, this new node is lost. All right, and when you return head, so head in the main, okay, gets the value from head in this insert function. Okay, and this is in the main of type node pointer. Since the value in this head in the insert is returned, this is pointing to this, so this also keeps pointing to this. Okay, So now when I do insert at end with all my values, I'm going to insert at end 2, then 33, 897 and print the linked list after each of these operations. Okay, so when the linked list is null, you get an output null to demonstrate empty linked list. Then we get, after inserting 2, this is going to be head 2 and null. Okay, head is pointing to the first node, which is 2. Then you insert 33 at end, so 33 comes after 2. Then you insert 8, so 8 comes after 33. Then you insert 100, so 100 comes after 8, and then one last print to insert 97. Oh, this is here, so I say 97. Okay, gcc insert node 2 it is, right? Okay, dot slash insert node 2. Okay, so 2 null, then 233 null, 2 and null, then 2 and 33 and null, then 233 8 null, 233 800 null, 233 897 null, the way we discussed. And then finally 65, because that's what we took the example of, so this had to be 65 and null. Okay, so you see 65 at the end. Okay, so behind the scenes this is happening, but if we want to understand in simple visual diagrams, you are basically inserting values x equal to 2, 33, 800, 97 and 65 to a list which is pointing to null. Okay, when you insert 2, head is null, now head is pointing to 2 and null. Okay, when you insert 33, head keeps pointing to this, the next of 2 becomes 33, the next of which becomes null. When you insert 8, the next of 33 becomes 8, the next of which becomes null. Okay, when you insert 100, the next of 8 becomes 100, the next of which becomes null. When you insert 97, the next of 100 becomes 97, the next of which becomes null. When you insert 65, the next of 97 is 65, the next of which is null. So eventually you get head 2, 33, 800, 97, 65 and null. Okay, so let me just, for these values 2, 33 and 8, demonstrate what happens behind the memory. Okay, all right, we start with head equal to null, so we have a variable head of type node pointer, and this is your variable inside your main function. Okay, this is null. Okay, then you call this function insert at end with head and 2. Okay, so when you call this function, you come here and this function will get its own set of local variables, so it gets head and x. Okay, own set of local variables, so you get a head of the same type node pointer, but this is inside your insert function. Okay, and it also gets x which is of type int, and this is also inside insert. Okay, two local variables. Okay, all right, so the first call we make to this function is with head and 2, so the value in head goes to, copies to this head inside insert, and we are sending x equal to 2, so x gets 2. Okay, we are here, we say head equal to null. Head equal to null will be true in this case because this head is null. Now as long as we are in this function, the local variable of this insert function is used, which is this one. Okay, it is when the function returns and we go back to the main, then head of the main function is used. Okay, the variable name is the same, the copies are different. Okay, you say head equal to null is true, head equal to null is true. We come here, we say head equal to new node. Okay, so dynamically a new node is created and then head points to it. So now this head points to a new dynamically created node with the value x and next. Okay, right now they are garbage values when we are here. Okay, when you set x equal to the given value x inside head, x of it set gets to 2. Okay, and the next goes to null, so I say this next now. This is 2, this is null. Okay, and since head is pointing to this, so this is not null anymore, this is some value, some address. Okay, All right. So after these three lines, head is pointing to this dynamically allocated node struct. X inside the node pointed to by head is 2. Next inside the node pointed to by head is null. Okay. And then we return head. When you return head, you come here. You're basically copying the return value into this variable. Okay. So this head gets the value which was inside this head. So suppose if this was addr1, where this at the address at which this struct was given. Okay, so this also gets addr1. Okay, the value is being copied here. The value in the head variable of the insert function is copied into the head variable of the main function. Okay, now since this is the pointer to this node, this also is now the pointer to this node. Okay, and after the function returns, we lose all the local variables. We lose this, we lose this, so we lose this link as well. Okay, so after the function returns, what remains is this part only. Okay, you have a head in the main storing addr1, the address of this allocated struct, the next of which is null, which is just getting you the first node. Okay, so inserting x equal to 2, head in your main was pointing to null, you made your head point to 2, and the next of this is null. Okay, just as here. Okay, so you see how when the list was empty, we created the first node. Now when we insert, since 2 is inserted, okay, now when we insert 33, you see we create a new node at the end. Okay, so this node comes after 2. All right. Okay, so calling this function again with head and 33, so again it gets its own head, okay, a local variable of insert, and x, a local variable of insert. X gets the value 33, head gets the value from the head variable in the main, so it gets addr1. So it is a pointer to this node now. Okay, in the second call we are here. Okay, after this function gets all its local variables, head equal to null, we check, this is now false. Head equal to null, you come to the else part, you say current is head, you create a new variable, okay, current, okay, of type node pointer, copying the value in the head addr1, so this is the pointer to this node as well. Okay, of part, and it is in insert function. Okay, you say while current.next is not equal to null, current.next is not equal to null. Okay, current's next is null, condition is false. Condition is false in the very first iteration, so you come out of the while loop and you say, and the comment says current is at the last node. This is the only node, so this is the first and the last node, and current is pointing to that. Okay, then you create a new node. Okay, so you create a new node, okay, variable new node, okay, storing address of where this new node is creating, say addr2, pointer to this new node, so this is a node pointer inside insert function. Okay, gets its x and next. Okay, both are some garbage values when we just allocated memory. Then we say node.x is x is 33, this gets 33. Okay, and the next is null, so this is now null. Okay, let me just clear this, 33 and null. Okay, we are here. Then you say current.next is new node, so whatever value was inside this variable new node is copied to the next of current. Whatever value was inside this new node is copied to the next of current, so this gets the value addr2. Okay, since this gets addr2, the next of current is now a pointer to this. Okay, so let me just clear this, this is no more null, this stores addr2, pointer to this node, okay, and head is still pointing to this node. Okay, all right, your else part is complete, you return head. When you return head, you go back to the main, so the return value from this function is copied to the head in the main. Return value from this function, value of the variable head in the insert is copied to the variable head in the main, so addr1 is copied back here, so this stays addr1. Okay, function returns, we lose all local variables, we lose current, we lose x, we lose head, which was the local variable in your insert, we lose new node. Okay, so we lose this link, we lose this link. Okay, the only thing that remains after the second function call returns is head storing addr1, which is the address of this node. The next of this points to this node, the next of this is null, so we lose this. Okay, we lose x and head, we lose this link, we lose new node. Okay, and this is addr1. Okay, so head stores addr1. Okay, and this is what you get after the second call with x equal to 33. So you see, when you inserted 33, a new node with the value x equal to 33 was added at the end of the last node. Okay, so your list is head to 33 null. Okay, so when you add 33, it is head to 33 and null. Okay, I'm going to quickly do one more iteration for 8. So you get x equal to 8 now, local variable inside the function x, local variable inside the function, okay, head in the function insert, gets the value from head in the main. So this is also addr1. Since this is the address of this node, it points to this node. Okay, we are here. Okay, we have all the local variables. Okay, head equal to null is now false. Okay, we are here now. We say current equal to head, again we get a variable, okay, current of type node pointer inside the function insert, okay, storing the value in head, which is addr1. So it is also a pointer to this node. Okay, then you say current dot next is not equal to null. Current dot next is not equal to null. Current next is an address pointing to this node, so condition is true. Okay, this condition is true. So you say current equal to current dot next. It means whatever value is inside current's next is copied to current. Current's next contains addr2, gets copied to current, so this stores addr2 now. Okay, current stores addr2 now, so this link of current is pointing to addr2, which is the address of this second node. Okay, then you go back to check for while loop condition. Current dot next is null. Current's next is null in this case, so current stops at the last node now. In the previous iteration, when we were inserting 33, this was the last node. In this case, this is the last node with x equal to 33. Okay, current is at the last node, current as the last node. We say create a new node, so a new node is created. Okay, so the variable new node, okay, of type node pointer inside insert function, okay, stores the value addr3, which is the address where this new struct is given. Okay, and it has its x and next part, which are both blank right now. Okay, some garbage values, not blank, garbage values, blank is the wrong word. Then you say node of x is x, x is 8, so 8 gets copied here, and then you say node dot next is null, so we have null here. Okay, all right, and then you say current dot next is new node, so whatever value is inside new node gets copied to current dot next. That is saying wherever new node is pointing to, current dot next is going to point to that. New node is pointing to this, current next is going to point to this, so this is now changed to addr3, and this points to this location. Okay, function returns, so you return head. When the function returns, the value in the head of the insert gets copied to the head in the main, so this gets overridden to addr1, basically stays addr1. Okay, we lose all local variables when the function returns, so we lose new node, we lose this link, we lose current, we lose this variable, we lose this link, we lose x, we lose head, we lose this link. Okay, only what remains is head in the main storing addr1, the address of this struct, the next of which is storing this, the next of which is storing this, the next of which is null. So we lose all our local variables. Okay, so now your linked list is head pointing to 2, then 33, then 8 and null. So basically you created a new node 8 and you set the next of 33 and the next of 8. Okay, so you see how the insert at end is working. Okay, one final thing is, if we don't return the value head, okay, there is going to be no node added. Okay, so I'm gonna do this, copy this. Okay, so we are inserting at end, but we are not returning the value in this case, so the head in the main is not getting updated. Okay, because head in the function call is a separate value, a separate variable with a separate value, and head in the main is a separate variable with a separate value. Okay, so now when I clear and run this, you will see we get only null. Okay, this is happening because, so we have again this. Okay, your head was pointing to null when the list started, and this is your head of type node pointer. Okay, inside your main function. Okay, the first value we inserted what x equal to 2, so you get a variable x equal to 2 in the uh, insert function, right? Int type in insert. Okay, and you also get a head with the same value from the main, okay, of type node pointer, and you say insert in the insert function. Okay, insert function gets these two local variables. So in our first function call here, okay, head gets the value from the head in the main, copied, null. Okay, x gets 2, we come here. Okay, we say head equal to null, head equal to null is true, so we come here, we create a new node, head is pointing to that node. Now we create a new node at some address. Okay, okay, and head is pointing to this new node now. Okay, so say this is at addr1. Okay, then you override the x value to x, x value to x, you set the next to null, next is set to null. Okay, and then you return. Okay, you simply return from the function, but you're not returning value. When you return to from the function back to the main, you are coming back here. Okay, since no value is being returned, we lose all local variables. Okay, and since no value is being returned, this head in the main remains null. It is not being overwritten to the new head. Okay, and that's why we get all null cases here, because we are never updating the head in the main. Okay, that's why returning the value of head is important, so that whatever changes, okay, are made to the head in the function are reflected back in the head in the main. That is why we return the head from the function. Okay, and this is also a case of a memory leak. Okay, because this is dynamically allocated, there is no reference pointing to this memory. How do you free it? Okay, all right, so this was your concept that goes behind inserting a new node at the end of the linked list. Okay, right, so overriding the head in the main is important. Okay, because whatever changes are made to this head variable, you have to reflect it back in some way here. Okay, sometimes the pointer to this head is passed, that is a double pointer is passed, node pointer is passed. We can do that as well, we can discuss that in a later video. Okay, so this was to insert a node at the end of the linked list, and I hope you like this was helpful. So if there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve, or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.